Hello. All right, so we have now learned all of the different types of conics. We have circles, parabolas, ellipses, and hyperbolas. And we've focused mostly on their graphs. Today we're going to look at them from a more algebraic sense. And so the equation that we are used to for all of those typically has parentheses in it, has this quantity squared, has fractions, and it's kind of tricky to do algebra with all of that stuff going on. So we're going to look at a different form. That's called standard form of those equations. That's what we've been using with the parentheses. And standard form is awesome for graphing. We're going to convert things into general form. Well, actually, I take that back. We're going to be looking at general form today. And general form looks like this. It doesn't have the parentheses or the fractions going on in it. What you're going to have is some sort of an equation. Once you multiplied it all out, got rid of the fraction, got rid of the parentheses, you're going to have some term that's an x squared. You're going to have some y squared term. You'll have just a plain old x term, plain old y term, and you'll have some kind of a number. All right, so this is what general form looks like. Now, that's actually general form for all four conics. But each of the four conics kind of has their own twist to this general form that distinguishes which conic you're looking at. So for instance, in a parabola. Okay, now remember a parabola is like y equals x squared or x equals y squared. So there's really only one squared term. So you're going to notice in the general form that either a, and I say a or b is equal to 0, which really means this whole term would not be there. Or possibly this whole term would not be there. So you're only going to have one squared term in the equation. That's going to be your clue that you're looking at a parabola. Okay, now for it to be a circle, both of those squared terms will be there, but what's going to force you to go left and right and up and down the exact same, creating a circle, is for this a value, or this coefficient on your x squared, to be the same as the coefficient on your y squared. Those would have to be the same. Then we'd have a circle. All right, on an ellipse, a and b are the same sign, so they're both positive typically, but they could both be negative, but usually they're both positive. But they're not going to be the same number this time, because if they were the same number, we'd have a circle. An ellipse, you go up, down, left to right, different numbers. That's what makes it elongated. And then the last one is the hyperbola, and it says that a and b are different signs, meaning there's going to be a subtraction. Remember on your hyperbola equation that we typically have subtraction going on? So you're going to usually see this be a subtraction, or maybe you'll have a negative out in front of one of them. All right, so the first thing that we're going to do then is practice. If you look at an equation, do you know what it is? So you've got this for your notes. Let's look at a whole list of these. So just looking at each equation, can you figure out which conic each one of these is? Okay, so if you would just take a minute, you're going to pause the video and just write like an E for an ellipse or C for circle, and just write it out to the side. See if you can figure out which one of these it is. So go ahead and pause the video and do that. I'll wait for you. All right, check yours, see if you match. On this first one, it's an ellipse because these are both the same sign, but not the same number. This one's a circle because they are the same number. We assume there's a 1 in front of each of those. This one's a parabola. There's only the one squared term. Another ellipse because these are both positive but different numbers. Here we have a hyperbola because these are different signs. We've got the subtraction going on. And a circle, again, these two are the same coefficient. Okay, so once you have figured out what it is, then what we're going to work on is, okay, this is great to do algebra with. And so that's why we have the general form, and tomorrow we're going to do some of that algebra. Today I just want you to be able to go between the two forms. So I'm going to give you this equation, let's say, and you're going to have to be able to turn it back into that standard form that we've been working with so that you could graph it if you wanted to. Now, what that's going to take is some completing the square. So let's start off and let's just refresh our memory from Algebra 2, how to complete the square. And really, if you just want to watch on this, you don't need to take notes on this part because we're going to tweak this concept a little bit, but I just wanted to refresh your memory. When we completed the square, the first thing we had to do was make sure that this coefficient was a 1. So we would factor out a 3. So we're pulling out a GCF. Okay, now you have to pull out a GCF between the first two terms. We're not really looking at the 14 right now. In fact, I always like to move that 14 to the other side to get it out of the way. So let's go ahead and do that. So when I look at these first two terms, I see that a 3 could go into both. Actually, it doesn't even matter. Now I'm going to give you nice ones, but you basically are always going to factor out whatever this coefficient is because you want that to be a 1. I'm going to give you nice ones that always divide nicely. So I'm going to factor out the 3. Remember, only the number. We're not worried about the x's right now. So then this is going to become x squared plus 8x. And remember, I'm going to move this 14 to the other side. But the completing the square is actually you putting a number right here to complete this trinomial and make it a perfect square trinomial. That's what our goal is. So I leave a blank here because we're going to add a number, but then I'm going to go ahead and show that I moved that 14 to the other side. Okay, so that's your first step, is kind of the rearranging, moving the constant to the right, and then pulling out that leading coefficient. Now, to complete the square means to find the number that you want to put right here that's going to create this as a perfect square trinomial. To find that number, we always took half of your middle term, that half of 8, and then square it. So half of 8 is 4, squared is 16. So I'm actually going to put a plus 16 right here. Now, the one thing that you have to watch out for is this is an equation and it's supposed to stay balanced, so I can't just randomly stick a 16 here and not do the same thing on the other side of the equation. And in addition to that, when I put this 16 right here, it's actually getting multiplied by this 3. So when I wrote 16, what I actually wrote was 3 times 16, which is 48. So I have added 48 to the left side, so I'm going to have to add 48 to the right side to keep it all balanced. All right, so then your next step is to factor this trinomial that you created. And if you created it correctly, it's always going to factor to a binomial squared. And so what this would factor to is an x plus 4, or what we would call is x plus 4 squared, equals, and 14 plus 48 is 62. All right, and so this one is a problem from Algebra 2 where actually completing the square was a method to solve quadratics. Like if you didn't want to factor and you didn't want to do quadratic formula, you could complete the square. And so you would keep going from there to do some stuff to solve this. But this process right here is what I was trying to refresh your memory on, is how do you complete the square? Okay, so let's look at it from our point of view with a conic section. All right, so here we have a nice general form equation, and we're going to complete the square to get it back to that standard form that we're used to using. Now the first thing you have to do is look at this and know what you're looking at. So look at your coefficients. They're both positive, but they're different numbers. So this is actually going to be an ellipse. So keep that in mind. You want your equation to look like an ellipse equation. Now, what's trickier about completing the square is that we have two variables going. In Algebra 2, you just had the x. Now I've got x's and y's, and I'm actually going to complete the square on both of them. The first thing I want to do is get my x's together. So I'm going to get my 9x squared and then my plus 36x. Then I'll do my y's, 4y squared and minus 24y. And then I'm going to move that 36 to the other side and get it out of the way. All right, so now let's look at just the x's. Remember that you want this coefficient to be a 1, so I'm going to factor out a 9. And I'm going to have x squared plus 4x plus something. Close it. Plus, now we're going to do it with our y's. We need the coefficient on the y to be a 1, so I'm going to factor out that 4. All right, when we pull that 4 out, we'll have a y squared minus 6y plus something equals negative 36. All right, let's complete the square. So we take half of this middle value, half of 4 is 2, and then square it. 2 squared is 4. But if I put this plus 4 right here, I've really put 9 times that, so I put a plus 36. So that means over here I have to also put a plus 36. All right, so now we go to the y's. And I look at this middle term. Half of 6, and it's actually half of negative 6 is negative 3, but then you're always going to square it, and that's always going to make this be a plus sign. So half of 6 is 3, squared is 9. So I'm going to put a plus 9. But by putting a plus 9 there, I actually am putting a plus 36 again. So let's add another 36. Okay, kind of a coincidence. These are all 36s. All right, so let's see what we have left. We're going to have this 9 out in front. This is going to factor to a binomial squared. It would be x plus 2, or we write it as x plus 2 squared, plus, then we have the 4, and I'm going to have a y. Now notice the sign here is actually going to be a minus because the 6y was negative, and it'd be y minus 3 squared. This number is always going to be whatever you squared. So here I took half of that number. That was my 2. That's always going to be what goes here. Half of the 6 was the 3, but it was a negative 3. All right, and so then let's finish that up. What we end up with on the side, once we add all of these numbers together, a couple of those 36s are just going to cancel out, and I'm left with a 36. Okay, so if you remember, this is an ellipse, and ellipse equations always equal 1. This one equals 36. The other thing that ellipse equations have are fractions, and this one doesn't. So we're going to fix both of those issues in one shot. What you're always going to do is take whatever number you have over here, and you're going to divide it by itself, because that is going to get you your 1. But then you have to divide everything by 36. So I'll do this. Okay, and then what's going to happen for us is these numbers here are going to reduce, because on our ellipse equation we never had that coefficient out in front. That should divide out with your denominator. Same thing here, should divide out. Now look how beautifully these are going to divide out. That doesn't have to be the case, but I'm going to be nice to you, and it should happen that those divide nicely. If they're not dividing nicely, you probably did something screwy over here, like you forgot to add these numbers, or maybe you forgot to distribute before you added your number. And so check that. Make sure that whatever you're dividing by should reduce nicely here. If not, go back and troubleshoot. All right, so in this case, I'm going to end up with an x plus 2 squared over 4 plus y minus 3 squared over 9 equals 1. And now that's my beautiful ellipse equation where I can find the center of the ellipse. I know I'm going to go left and right 2. I'm going to go up and down 9. And so what we've managed to do is take this nice algebraic equation and convert it to something that is going to be graphable for us. So this is our focus today, is just being able to switch to this form. Tomorrow we'll do more with this algebraically. Okay, let's practice again. All right, here's another one. Let's look at this general form equation and see if we can tell what type of conic it is. You should notice the minus sign right here, which is going to make this end up being a hyperbola. So it's going to actually be very similar to the ellipse we just did. So think about what a hyperbola equation looks like. That's what we're shooting for. All right, so step one, get those x's together. Get the y's together. Move the 18 to the other side. Now let's factor out that leading coefficient for each variable. So we're going to factor out a 9 on the x's, and the y's actually has a -1 here that we'll factor out. So on the x's, factor out the 9, and then leave a gap where you're going to complete the square. And then on the y's, it's actually a -1, and even if there was a number there on a hyperbola, you have to factor the negative out. That's what gets us the minus sign that we want. So we're going to have a -1 factored out, which gets us a y squared plus 6y plus something equals -18. All right, so now you take half of 4 squared, so that's going to be 4, which really gets me a 36. So let's add 36 to this side. And now let's do the same thing on the y's. Half of 6 squared is plus 9. But when I put that plus 9 there, what I really put was a -9. So let's put a -9 on this side. And then that's the completing the square. That's what we've done. So that should now factor nicely to 2 nice binomial squared. And this is going to be a -1. And this is going to be a y plus 3 squared equals, over here I end up with, looks like a -9. No, it's going to be a +9. Sorry. All right, so then your last step is to divide by whatever you ended up with. And I always take a minute and make sure, is that a good number? Is that going to divide nicely with these coefficients? And it's going to work great. If not, go back and troubleshoot. All right, so then my final answer ends up being, the 9's cancel out, so I have an x minus 2 squared. Now really, you know, if they totally cancel out, we wouldn't probably even write it as a fraction, except I kind of like to see that denominator, because remember that's going to tell me how big to build the box on the hyperbola. So I'll leave the 1 there. Then this negative makes it a minus. Y plus 3 squared, it's going to be over 9, equals 1. And there's my equation. All right, let's try one more. All right, so now if you look at this, there's only one squared term, so that's our clue that this one's a parabola. So we will have done an ellipse, a hyperbola, and a parabola. What I haven't done was the circle. Okay, the circle is probably the easiest one because we don't care if it equals 1, and so it's going to work very similar to the ellipse and hyperbola. You just don't have to do that division at the end. The parabola is definitely a different type because we only have one variable that's squared. We're only going to be completing the square once, not doing it on the x and the y. And sometimes you'll do it on the x, in this case because the x is squared, but remember those sideways parabolas have y's that are squared. Then you'd only complete the square on the y. So looking at this one, remember where we're kind of headed with this. A parabola equation looks like this. Y equals a x minus h squared plus k. That's the look I'm going for. All right, so I kind of start off the same way where I'm going to pull out not a GCF, but pull out the leading coefficient. This one doesn't even have one, so I'm in luck. It's just already a 1, so I won't have to pull anything out. But I do also want to get everything that I'm not completing the square with to the other side, which actually means both of these need to go to the other side. So I'm going to have my x squared plus my 4x plus something equals, and I'm going to move my 6y and I'm going to move my 2. Okay, half of 4 squared is 4. I didn't have a number out in front that has to get multiplied by, so I'm going to go ahead and just do plus 4 on this side. So then that becomes x plus 2 squared equals negative 6y plus 6. And now let's look at what's kind of how this is different. On my equation, I'm really just trying to get the y by itself. So that means I'm trying to get this y by itself. So I'm going to move my 6 over here, and then I'm going to have to divide. So let's subtract that 6 first. And then I'm going to divide by negative 6. But I have to divide everything by negative 6, so that's going to be this right here, that number that's out by itself, and this quantity here. Alright, so that's going to cancel out beautifully, and I'm going to have my y by itself. Now I'm kind of a fan of having that y over on the left side, so I'm going to kind of swap this whole mess. I'm going to put my y on the left. So it's going to be a y equals. Okay, the next thing that's kind of weird is this mess right here. We don't have a fraction like that on our squared term. But what this fraction actually represents is my a value. So instead of showing it as divided by negative 6, that's actually just a fraction, negative 1/6. And that's that a in my equation. And then I'll have an x plus 2 squared, and then a negative 6 divided by a negative 6 is a positive 1. And now that looks like the parabola equation we're used to seeing that we could go graph. Alright, so on your homework today, you're going to practice first with just some completing the square, just getting it into that form, and then I'm going to have you do some where you have to complete the square, get it in that form, and then do you remember how to graph it? Okay, so good luck with it.